Okay, today I'd like to introduce you to sine curves. Very important idea because so many different things follow a pattern that looks exactly like a sine curve. So for instance, if we were to look at the length of the day in terms of how many hours of sunlight are there in Franklinville, New Jersey, and we were to plot it over the course of about 800 days, we would see a pattern that looks exactly like a sine curve. You'll notice that the average value for the length of the day is about 12 hours. You'll notice that in the summertime, we get about 3 extra hours of sunlight, and you'll notice in the wintertime, we get 3 hours less than the average, okay, on our most extreme day of the year. You'll notice that this spot right here turns out to be the first day of spring. That's where we are right now. We are at a time where we get about 12 hours of daylight, and each day we get a little more daylight than we had the day before. When we hit June 21st or thereabouts, we will peak. We will hit the maximum amount of daylight, which is about 15 hours. When we get to December 21st, we'll hit our minimum. We'll get 3 hours less than our average. You'll notice that this starts not at the very bottom, but it starts on January 1st, which will be a little bit beyond the bottom. Okay, so this is what a sine curve would look like, and one that you can relate to because you experience it during your life, and every year we go through the same pattern. If we lived in Stockholm, Sweden, we'd have the exact same shape. We would still average 12 hours of daylight, but when we hit the middle of summer, we'd get almost 18 hours, which gives us 6 more hours than the average. We pay for that in the wintertime when we get 6 hours less than the average, which bottoms out of around 5 hours of sunlight. 6 hours of sunlight. Okay, so we'd like today to learn how to actually write equations for these sine curves. So in general, this is your equation. Y equals A times sine of B times T plus C plus D. A, B, C, and D are all variables. Time represents the x-axis, and our y-axis could be incredibly fluid. Sometimes it might be position, sometimes it might be air pressure, it could be electric field, magnetic field, voltage, all kinds of different things. So we are not worried about what's on the y-axis. We're going to leave it generic and just call it y. Okay, we want to know, what do these things do? What is the purpose of A, B, C, and D, and how does it affect our sine curve? Let's start with the D value. Right now our D value is 20. Watch what happens to the graph as I change it. 30, 40, 20, 19, 18, 17, all the way down to 15. So you'll notice the D value shifts the graph up and down. The D value actually tells you how far the middle of the graph is from the x-axis. Okay, so one more time. The D shifts the graph up and down, and the value tells you how far it is from the middle of the graph to the x-axis. A value. Let's leave D at 25 and let's change A. So you'll see as I make A bigger, the graph gets taller. As I make A 0, the graph disappears. And as I increase A again, the height of the graph changes. Notice, regardless of what I make A, it does not change the center. It does not change the average. That's 25. What the A represents is how far do we get from the average. We get 10. 10 above, 10 below. It tells you how extreme your extreme points are going to be in terms of how far they are from the average. It's called your amplitude. For sound, it will tell us how loud the sound is, and for light, it will tell us how bright the light is. C-value, what does that do to our graph? Well, let's change our C-value. Notice that the C-value is written in terms of pi, and notice that when we increase it, the graph moves. Okay, so different C-values will shift the graph right or left. And if you watch, we're going to start at 0. As we make the C-value bigger, you'll notice how the graph moves to the left. This is called a phase shift, or horizontal shifting of the graph. It doesn't change the average, it doesn't change the height, it just shifts the graph left or right. There are 4 important C-values that you need to be able to understand. The first is 0. So if you have 0 pi as your C-value, your graph will start right where a sine curve is supposed to start. It'll start at the average value heading toward bigger values. If, on the other hand, we make it half a pi, it won't start at the average. It will start at the highest possible value. It'll start at its most extreme value. Okay? So that is a phase shift of 1/2 pi. If we shift it even farther to 1 whole pi, you see we're right back to the middle, but now instead of heading toward more extreme values, we're heading toward the x-axis. We're heading toward smaller values. Okay, so that is a phase shift of pi. One more that we want to look at. We want to shift it by 3 pi over 2, or 1/2 pi. You'll notice we are now starting at the smallest possible value, and then we're going through our sinusoidal pattern. If we had shifted it even farther, we get right back to where we started. So let's take a look at that. We're going to shift it not by 1/2 pi, not by a whole pi, not by 3/2 pi, but by 2 pi. Okay, and you'll notice we're right back where we started. 2 pi represents 1 complete cycle. Here are pictures of the 4 most important C-values. Please draw these pictures with the associated C. So a C of 0 starts in the middle, heading toward more extreme values. At pi over 2, you start at the most extreme value possible. At 3 pi over 2, you start at the closest value. And at pi, you start at the average, heading toward the smaller values. Okay? So pause it if you didn't get them all, and make sure you have these 4 important phase shifts. Finally, our B values. And the way our B values work is our B values are going to be multiplied by 2 pi instead of just pi. And if you watch, when B value is 1, it looks like that. As we increase the B value, you'll notice that the period becomes smaller and the frequency becomes larger. A higher B value means more sine curves per second. In fact, if we set this thing at a B value of 5, we will notice 1, 2, 3, 4, 5. Perfect. 5 sine curves per second. So this 5 represents the frequency. So the B value is the frequency times 2 pi. So I know we went through it quick, but each of these letters has meaning. The D tells you where the center of the graph is. The A tells you how high you get from that average value. The C tells you how much you shifted, and there's 4 important C values. And B tells you how many sine curves you're going to get per second. Remember, the B is the number of sine curves times 2 pi.